This is our Arduino Tutorials app that teaches users the very basics of putting together an Arduino with AR space and AI integration. This app was created by Chad Moss, Spencer Lott, Dempsey Lumet, Hank Davidson, and Stephen Drain.
I was the project manager for the project. I helped with programming and testing our product and worked closely with our team and faculty to create a shared vision of our product.
I was a programmer on this project working alongside Chad and Dempsey to create this app.
I worked on the code for the ChatGPT API key integration.
I helped out with coding and problem solving during our group meetings, along with assisting others when and where needed.
I was the artist who worked on the models and animation of the Arduino.
This app started as an app to help teach fellow GIM students how to work together in teams. This was because of our shared troubles with working together with other students in our freshman year on other GIM projects. We pivoted to this idea to working together on Arduinos, as it's one of the only physicalized objects that we work with in GIM. Finally, we landed on a singular tutorial for students to follow along to an Arduino tutorial that is similar to our Arduino class, with an AI checker and checkboxes to make this progress smooth. Our goal is to have an app be a framework for future teams to implement their own tutorials to assist onboarding and or teach incoming students with the help of digital twinning and AI, all centered in the AR space.
One of the primary challenges we encountered was our initial goal of allowing users to scan their own Arduino components and interact with them in the environment. In practice, this proved unworkable. The small size and fine detail of typical Arduino parts made them difficult for Apple's LiDAR scanner to reliably detect and reconstruct with sufficient accuracy. As a result, we were unable to proceed with this feature as originally planned and instead shifted to a manual pipeline where Spencer created detailed 3D models and textures for each required component. Another challenge we encountered was with image recognition. Our initial plan relied on ChatGPT's photo recognition to identify where Arduino components and wires were connected. However, the system struggled to consistently and accurately interpret these small, detailed connections, especially in varied lighting and angles. Because of this limitation, we pivoted to a more reliable approach, having users manually compare their physical build to a reference 3D model to verify correctness. The final challenge involved integrating the ChatGPT API. Requiring users to manually input their own API keys proved unreliable, as it frequently resulted in errors such as invalid API key, even when the credentials appeared correct. To keep development moving forward, we temporarily transitioned to using a hard-coded API key for testing purposes, with the understanding that a more robust and user-friendly authentication method would be needed for a final implementation.
We made these models and animations as a way for users to easily reference the Arduino parts using AR space. The goal was to make easy-to-follow guides for users to clearly see the project references without having to navigate away from the application. Working to integrate the models into Swift was a unique challenge. I wanted to ensure they displayed correctly and it was easy for users to connect what was available to them with what was on screen and able to be interacted with. The end result is multiple parts novice users can identify and see project progress to guide them through learning this specific medium of Arduino parts.
Here is our app demonstration. First, the user taps 4 corners on the table to spawn a work mat to keep track of the materials they will need for this project. Then the first step is to spawn the reference material they will need to move forward with the tutorial. Once the user taps the objects into the scene and sees what they need to do to finish the step, they do the same with their own Arduino parts. The user then follows the checkboxes to make sure they did everything correctly and can send an image of their workspace to ChatGPT for another round of checks. Then, they move on to the next step after an animation plays of what they accomplished. This repeats until they finish the Arduino hardware and can now program the correct script to go with this build. The really nice thing about our app is that this app is very easy to edit and create new steps or tutorials for any scenario.